Okay, today we're going to be looking at a type of math, a type of counting principle called permutations. And a permutation is an arrangement of objects in which order is important. So this is kind of like the key part of the definition. So when you're counting things, the order is important. For example, the 6 permutations of the letters A, B, and C are shown. So it's the different orders in which those letters can be in, and there are 6 of them. So you can use the counting principle to count permutations. Each time you choose a letter to make a permutation of the letters A, B, and C, the number of remaining letters that can be chosen decreases by 1. So it would look like this. So the total number of permutations, the choices for the first letter, since there are 3 letters, you have 3 choices. Once you pick that letter for that first choice, the second letter only has 2 possible letter choices left. Once you select that letter, there's only 1 more. So when you multiply those together, 3 times 2 times 1, you get the final answer of 6 different ways they can be arranged. The expression 3 times 2 times 1 can be written as 3 with an exclamation point, and it's read 3 factorial. For any positive integer n, the product of the integers from 1 to n is called n factorial, and written n factorial. So it's basically taking n and then times, and then n minus 1 times n minus 2 until you get down to 1. And the value of 0 factorial is defined to be 1. And this is a bit confusing concept for students. However, you have to realize that what we're talking about is a method of counting, and how many ways can you count 0, and that would be at least 1 way. So it's defined that way, and when we use our technology and our calculators, you will be able to experiment with that. So let's take a look at an example. So you have 4 posters to hang in your room, and you want to put 1 poster on each wall. How many ways can you arrange the posters? Well, you have 4 choices for the first wall. Once you make a selection, there's only 3 choices for the second wall, 2 choices for the third wall, and 1 choice for the last wall. So basically, it can be arranged as 4 factorial, and multiplied 4 times 3 times 2 times 1. There are 24 different possible ways to arrange the posters. Suppose that you had 7 posters and you want to choose 1 for each wall. You can use the counting principle to count the number of possible arrangements of the posters. Now what's going to be different is your starting number. So this is like taking, you have like 7 items taken 4 at a time because there's only 4 walls to divvy them out. So how many choices for the first wall? 7. How many choices for the second wall? 6. Then 5. Then 4. Now this is not 7 factorial, because 7 factorial would take us all the way down to 1. But you multiply it together. It's a lot of choices. These things kind of get pretty quick to multiply and get large. So we're going to be dealing with some large numbers at times. So this situation is an example of finding the number of permutations of 7 objects taken 4 at a time. Notice that 7 times 6 times 5 times 4 can be written as, and this is important because you will be asked at the end of this slide, PowerPoint, to write this using factorial notation. So because of the fact that it's not 7 factorial. If it were 7 factorial, remember, it would look like this on the top, okay? But since it ends at the 4, what it's being divided by is the 3, the 2, and the 1, because those cancel out, right? The 3's cancel, the 2's cancel, and the 1's cancel. So here's our definition. So the number of permutations of n objects taken r at a time can be written, and there's our the symbol, the n with the capital P and then the r. N things taken r at a time would be n factorial divided by n minus r, and then the factorial of that. So in that last example, we would have had 7p4, okay? So it would have been 7 factorial, and then we had 7 minus 4, right? Because what we had was 7 factorial over 3 factorial. So when you're looking at this and you had 7 times 6 times 5 times 4, and you want to write it using factorial notation, this is what you would write. Okay, and that's what I was talking about at the end. We're going to be looking at things like that. So the numerator would be the first number you started on, because that's the total number of choices you had to begin with. That's 7 factorial. However, there was limited because we are only taking them like 4 at a time, or 4 walls to choose from. So we have to get rid of, the 3, the 2, and the 1 for that 7 factorial. So that's why the 3 factorial, so 1 less than the last number, goes in the denominator. Okay, this is 5 things taken 3 at a time. So it becomes 5 factorial over 2 factorial. All right, and if that were written and I were asking you for the factorial notation, right, here's the factorial notation, what you would see is 5 times 4 times 3. And I would say write that using the factorial notation, and then you would have 5 factorial over 2 factorial. So again, things where order is important. Giving out prizes. So the judges at a science fair are awarding prizes to first, second, and third place. The science fair has 10 contestants. How many different ways can they give out for second and third? Now, granted, they're probably grading the science fair projects based on, the experiments, the scientific method, the conclusions, all of it overall. So in a way, it's going to go to the person most deserving. However, when you have 10 people enter, sometimes they like to count the possible outcomes, or maybe I would be asking you a question and say, what is the probability that you would win first place, right? And so we'd have to know the total number of ways that everybody else could come in first, second, and third, or all the different places and things like that. So we have 10 things being taken 3 at a time because there's 3 specific places. So we have 10 for the first place, 9 for second place, and then 8 for third place. So I won't necessarily expect you to write out all the work with the permutation formula. But I would like to see at the very least, I want to see this. So when I'm doing a factorial a permutation, and I look at the notation, I know that the number I'm starting on, n, is 10. There are 10 things to start with, and they were taken 3 at a time. So remember when we were looking at our counting principle, and we looked at the number of events and things like that, the first event is basically picking first place, then second place, then third place. So we have 10 contestants, then only 9 left to choose from, then only 8. And that's how you can get your work to count the total number. So that's 720 different ways that they can come in first, second, and third. Your garage has a keypad and used to open the garage door. The code has 5 digits. You remember that the 5 digits are 1, 3, 5, 7, and 9, right? So that eliminates some of the total possibilities because we know there's 10 digits if we didn't know that. So we want to be able to figure out how many possible ways can we arrange these numbers. There's 5 of them. So each possible code is a permutation of the digits 1, 3, 5, 7, and 9. The number of permutations of the 5 digits is 5 factorial, because when you have 5 things being multiplied together, you have 5 choices for the first digit, 4 choices for the second digit, and so on. So there's 120 possible outcomes, and you were asked, what is the probability that you open it on the first try? Well, opening it on the first try is the favorable outcome is 1 out of the total of 120. So this will help you be able to look at situations and count the number of outcomes, especially when they are relatively large. So let's evaluate 3 factorial. And when I ask you to do this, I don't necessarily mean use the notation on your calculator, however, show your work. So 3 times 2 times 1 equals 6. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1 equals 720. And 1 factorial. That's exactly like 0. Okay, how about 2 students are chosen from a group of 6 to read the first and second poems at a school's poetry reading. To find how many different ways the students can be chosen, find 6 things taken 2 at a time. So the permutation of 6 things taken 2 at a time. So again, you can use the formula. Or a much easier way, I think, is to just multiply the 2 things together, because if you have 6 things taken 2 at a time, all right, this R tells you how many factors you end up multiplying together. This N tells you where the factors start, and then you can get your answer. So that's a much simpler way to show your work and understanding of this more complicated formula. Okay, so find the permutations. So in this case, we have 1, 2, 3, start on 5, 4, 3, and the answer would be 60. For this one, 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. What is this example of? 6 factorial. And the answer is 720. So again, the R tells us how many factors? 2, 3, 4, 5, 6, and 7, starting on 8. And this is a large one, 40,320. Wow. Again, some of the products will be big. So we only have 2 factors here, but they are quite large. All right, so this last example, write the expression using factorials. So this is the one I was talking about, where we have the first number is our numerator. So if we had 23 factorial, remember that would take all the factors down to 1. However, the last factor we get to keep is 19, so we would have to put that over, is 20. I apologize, I'm already thinking ahead to what it is. So 1 less than that last thing, because this is like 23p4, right? That's what we're doing. So basically 23 minus the number of items gives you the denominator. So this has 1, 2, 3 items, so 57, and then 1 less than 55 is, oops, I can't say it or I'll write it, 54 factorial. Remember, because this is 57 things taken 3 at a time. So 57 minus 3 becomes that denominator. What about this one? So you have 71 factorial on top, and then it's 71 things taken 1 at a time, so 71 minus the 1 becomes 70 factorial, because the only one we keep from that is that first number.